So far, we've talked about a variety of different things. For instance, different coordinate systems like Cartesian, polar, tangential normal coordinates. We've also talked about relative motion of one object with respect to another. We've talked about motion of objects constrained to move together in some manner through pulleys or other things. All these topics sort of had to do with sort of application of calculus and or geometry to the study of motion without uh, referring to forces, without considering forces. And the study of sort of the geometry of motion and sort of the calculus of motion without considering forces is called kinematics. So that's this term, kinematics. I've not explicitly introduced it, but it's good to know this term. And what we've done so far is kinematics, okay? Today we're going to talk about kinetics, which is where forces come in a serious way. Kinetics is the study of the relationship between forces and motion, and essentially using F equals ma, at least for the near term, to try to understand how forces affect motion and given a motion, what forces are required to accomplish that. Okay, so that's kinetics as opposed to kinematics. Kinematics and kinetics. Okay, so the first equation, the most important equation that we learn in kinetics is, of course, the so-called Newton's second law. Okay, you can write this equation for a single particle or a collection of particle. Okay, applicable for a single body or a collection of bodies. So what does this mean? So let me just write two versions of the so-called Newton's second law. For any body, sort of a single object, say a particle, the sum of all forces on this object, on this body, equals mass times acceleration. Okay, you're all familiar with this. So you have an object here, and we have some force, F1, maybe F2, some other force, F3, etc. These are all vector forces. And then the object has some sort of acceleration in some manner. Then the sum of all forces, this means sum of all forces, okay, equals mass m times acceleration a of the body. If I want to say particle, okay, let me say particle here. Okay, so this times this. So that's the famous F equals ma equation. If you have a collection of objects, for any collection objects with masses m1, m2, etc., the sum of all external forces on these objects so let's call that sum of all external forces like that equals m1 times a1 plus m2 times a2 plus m3 times a3, etc., where this is acceleration of the, let me just say, where AI is acceleration of the mass mi. Okay, so if you have multiple objects, m1, m2, m3, that are, so like we have some multiple objects like so, and this collection of objects is acted upon by some external forces, F1, F2, etc. There may be internal forces between these objects, and they do not count in the sum of all forces. These are just external forces, okay? These are external to the system of masses. And each of these masses might have an acceleration a1, a2, a3, and it turns out that the sum of all external forces external to the system of masses equals m1a1 plus m2a2 plus m3a3, etc. Okay, we will primarily use this version where we consider a single particle sum of all forces, external forces on a single particle equals the mass of that particle times the acceleration a of that particle. Technically, it is the acceleration of the center of mass of the particle, but this is something that we will consider in more detail later on in the course. For a particle, because it doesn't really have any sort of, the dimension of it is not important, we will just treat it as a point and the center of mass coincides with where the particle is. Okay, so I'm just going to say acceleration of the particle. Later on, for sort of an object with a shape and so on, we will actually modify this to acceleration of the center of mass of a particle. Okay, so that's the main equation. You're all familiar with this version. I guess now you can get familiar with this version. Like I said, we will mainly use this one. Okay, so let me just write down the procedure for solving basic particle dynamics problems. For solving particle dynamics or kinetics problems, what's the first step? Okay, draw free body diagrams. And then actually FBDs. FBD stands for free body diagram. I guess you're all familiar with it. And you draw them as many as you need, as many as necessary. Usually as many as objects in the system. So usually, let's say one for each particle in the problem. When we say particle, we mean mass, right? So mass or particle. That's the first step. Second step is the next few steps are kind of usually merged together in some form. You don't have to necessarily think of them as distinct steps. So we define coordinate systems / sign conventions. The next step would be for each FBD or mass or particle calculate sum of all forces, and then for each SBD or mass or particle, write an expression for its acceleration for the accelerations. And then here you have a choice. You can use Cartesian or polar or tangential normal. Depending on the problem, you may need to use one or more of these coordinate systems to actually write an expression for the acceleration. Recall, we gave you formulas for acceleration in each of these things, and you might want to recall them and use them. I guess you can look up the formulas whenever necessary. And then, of course, for each particle, etc., do sum of all forces equals mass times acceleration. Okay. So those are the principles, and then you will have the usual principle is there'll be few quantities given, few unknowns. Eventually write as many equations as unknowns, and then solve. Okay, so that's the general procedure. Occasionally, I'm just going to write this down now. Sometimes need to use constrained motion to get additional equations. As F equals ma may not provide you sufficient equations. Okay, so this will become clear as we actually do example problems. So just to recap, how do you solve particle dynamics problems? You draw free body diagrams. If you have multiple objects, you draw a free body diagram for each object, let's say. And then you define coordinate systems and sign conventions, as you do. And then for each free body diagram, calculate the sum of all forces. For each mass or particle, write an expression for its acceleration in terms of whatever coordinate systems you've defined, which may be Cartesian, polar, or tangential normal. And then you do F equals ma. And then you'll have a bunch of given quantities and a bunch of unknowns. You try to write as many equations as there are unknowns so that you can solve them. Sometimes just writing F equals ma may not be sufficient. You may need to use things like constrained motion to find essentially additional equations relating different accelerations, like we did for pulleys, different accelerations. Example for pulleys. Okay, so I guess that's the end of this little video. We'll do some example problems now.